Okay, folks, sorry about that. There's some strange things which happen. Okay, so we're gonna get started here. Let me just get this on and. Okay, so the topic of today's lecture is mobility-related processes. And as we've done in previous lectures, we're going to be using AnyLogic as our sort of tool for examining some of these factors. The goal of today's lecture is not to have a exhaustive or really thorough coverage of mobility in AnyLogic, any more so than it has been in other lectures to very thorough coverage. We do have the videos online, which many of you people have been watching, which will give you more details about particular factors here. I wanted to use the opportunity instead to talk about some of the roles that mobility plays within the modeling process, give a glimpse for sure of how mobility can be realized in AnyLogic, together with a little bit on dynamic populations, because it's not something that I covered in a separate topic, although there is a separate video on it. And finally, a little bit on UI customization in AnyLogic, so just so you have a sense of how that's accomplished. As a reminder from videos that you folks should have launched, so one video that discussed spatial embedding in AnyLogic. I argued that in that lecture that spatial embedding is, this is really ugly, is very important for capturing certain types of essential dynamics where there's locality of influence over space. An example would be transmission of infectious diseases. And second of all, sometimes insight into certain phenomena that have spatial implications. So they give rise to spatial patterns of the sort that might require explanation or give a clue as to the character of the underlying processes. So in the very first lecture I think I gave in this class, first or second, you gave a glimpse of some spatial processes, whether it was the spread of Black Death in Europe, or whether it was the spread of rabies in New England area in the States, that have very defined spatial patterns associated with them. Finally, for many practitioners, use of spatial embedding is very attractive because it allows bringing in a whole set of information associated with geographical information systems, information related to the character of the landscape, certain localized features, whether it's water bodies or certain types of terrain, etc. So within AnyLogic, having motivated that discussion of spatial embedding, I had noted that AnyLogic supports two types of spatial embedding. One is continuous and one is discrete. In a continuous space, the idea is that distances are not quantized. Instead, they exist as real numbers. And individual entities wander over the landscape in a fashion that conceptually is associated with continuous movement. So there's a sense of continuity in acceleration and movement of, I shouldn't say acceleration, there can be acceleration, but the movement of the individual over the landscape occurs in as fine a detail as the time events allow. Now, the continuous embedding is notable not only for the fact that agents can be real distances, real numbers in terms of units apart from each other, but there's no sense of physical exclusion. The idea is that we're observing the landscape at such a high level that we don't have to worry about, per se, about the presence of one agent excluding the presence of another. So the agents are assumed to be small compared to the landscape, and they can pass arbitrarily closely. Now, your model can impose logic whereby agents that come within a certain distance of each other interact in some sort of way. they may collide, they may transmit infection or what have you, but that's not built in. The notion of sort of contact isn't built in to the environment, the continuous environment. Agents can be right next to each other, and there's no problem with that. And there's a number of models provided with AnyLogic, in which I can provide you, which illustrate this. The alternative is a situation where we have a discrete spatial environment. We have discrete cells, and each cell holds 0 or 1 agent. There's mutual exclusion. The cells tessellate the space. So in other words, they're exhaustive, spatially exhaustive. They completely cover the space, and they're mutually exclusive. There's only, for any given point in the space, there's only one cell that covers it. There's exactly one. So there's a number of models that exhibit discrete spatial environment, but fundamentally here it's divided into columns and rows. Physicists sometimes do more interesting things where they'll impose hexagonal grids, for example, atop series of underlying grids so that you can have connectivity in a larger number of directions. Fundamentally, there's going to be built into AnyLogic the capacity to connect up these cells to either 4 neighbors or 8 neighbors. So the 4 cardinal directions or all 8 directions. So not just north, south, east, west, but northeast, southwest, southwest, and northwest, etc. So here we're divided in a discrete environment. We're divided into columns and rows, into grids distinguished according to columns and rows, and there's physical exclusion. An agent can only be only at most one agent can be in a given cell at a given time, and that is enforced. Okay, so 2 different spatial environments. You comfortable with that? You should have seen that in the previous video. Okay, and I noted that AnyLogic's environment construct in AnyLogic 6, that's, and in fact 5 before it, that's where the parameters of this spatial environment are set, just as it set also network characteristics. So width, breadth, continuous versus discrete, and the nature of the neighborhood. Now, that was a little bit on sort of the environment supported in AnyLogic spatially. Why capture mobility? I'd like to give a few moments of motivation, a few minutes of motivation for this. And it really harks back, ladies and gentlemen, to some of the first few lectures in the course, where we talked about the fundamental need to scope models, the fact that a model like a map is an abstraction of reality, and like a map, it's useful precisely because it does hide details about the world. There are certain phenomena that are included, and there are certain phenomena that are excluded from that model, and thereby it helps lend us insight that's difficult to achieve in an extremely complex world. And I argued that the phenomena associated with the model can be divided into 3 categories: endogenous, exogenous, and ignored. Endogenous being the things that the model produces, generates. You can use different terms for it, meaning that it's actually calculated by the model and it's changing. It's driven by model dynamics. It's governed by the dynamics in the model. Exogenous factors may be pre-specified to change over time, but they're pre-specified. They're dictated beforehand. They're preordained how it will evolve. And finally, an ignored or excluded set of elements, which are consciously, hopefully, put aside as being outside the scope of this particular model. And I argued that there's some real trade-offs when it comes to choosing what goes where in those 3 categories. So maintaining factors as endogenous rather than simply exogenous or ignored gives us extra flexibility for capturing certain effects. The fact that we can reflect certain types of processes within the model allow us to ask what-if questions that involve alternative scenarios involving those processes. It allows us to talk about changing the system by intervening in some way in factors that relate to those processes. So it gives us, for example, extra flexibility for capturing effects of interventions, greater robustness in the context of change. There may be things that are changing these underlying processes, which we can capture because we've captured them in the model. And it may support a generality of the model to other contexts. On the other hand, it does require greater detail. Why am I talking about this here? Well, it's because mobility is one of those factors that a lot of agent-based models abstract away from. They deal with abstractions like networks and connectivity in networks, whether they be static networks with static predefined connectivity, whose topology is dictated ahead of time and stays fixed, or whether they be networks with dynamic topology, where the connectivity is changing over time. They abstract away from where the agents are in space. But as was the case when we went from, for example, random mixing in an SAR type model to a situation where we captured networks, there is a benefit from being able to take into account sometimes extra detail to answer certain types of questions. The goal is not, is one model right, but is it fit for certain questions? And we may choose to have a model that's more aggregate and that deals with a random mixing abstraction, a model that is, on the other hand, uses networks in a fixed way, a model that has networks with changing connections over time, or indeed a model which includes mobility, and where the contact between individuals, say, is driven by the mobility that those individuals follow. So we can characterize in a network-type context how frequently all pairs of individuals in this room interact. We could have a weighted graph where each connection between individuals, is associated with a certain real number representing the average number of minutes per day that that pair of individuals interact. And we could even make that network more precise temporally by having it change over time, so that certain people are more likely to be in contact at certain times of the day. Perhaps even in this class, we're in contact, and then we go off our different ways, and only some small subpairs remain in contact. We can do that through a network, but there are times where it's actually more responsive to the research question or the goal of a modeling study to advise people to make use of explicit representation of space and of movement over space. And in these cases, what was just a contact network, a graph with people connected, may be an emergent property of mobility, of contact patterns that take place as people are brought together or leave from each other. Those contacts we capture in the network might be effects arising from an underlying mobility process. And, if you're going to think about interventions which change mobility in some factor, in some way, it might be beneficial to have a representation where that mobility is explicit. For example, if you were to seek to try to stem the spread of flu from its inception in Dr. Osgood's classroom to its spread across the city in ways that could inflict great suffering and need for bed rest across Saskatoon's population, you might seek to affect mobility in the form of restricting certain types of contact. You might shut down Nut 394 and 858, prevent it from meeting, and the people therefore don't come together. And what you would see is an emergent contact network that may be quite different from if you didn't, if things were going business as usual. Similarly, you might close down Place Riel as a gathering point, and the individuals who take the bus wouldn't congregate there, and therefore they'd be less likely to bring the terrible strain of flu originating on the very stage of this classroom. and they'd be less likely to disseminate it via place real. So if we wanted to examine the impact of changing certain, of intervening at certain physical places, for example, or of changing changing people's mobility patterns, for example, by having children stay home rather than going to school to try to stem the spread of infection in schools. Representing a mobility type model might be desirable, either mobility to logical locations or indeed mobility over a geographic surface. Similarly, if one were simulating, Maria's not here today, I think, but if we were simulating the spread of a disease like chronic wasting disease among deer here in Saskatchewan, and you wanted to examine the effects of placing vaccinated food at certain places in the landscape on the development of herd immunity in the deer, then having a representation of where those items of food are placed might be useful, because you could realize greater benefits if they're placed in certain regions of the landscape than others, areas that are visited frequently by deer herds, like areas on the edge of watercourses, etc. So, we could represent using mobility, people's movement patterns, the contact networks we've been looking at in such detail in network structures might be emergent then. They would describe what's going on, but they're not the drivers. And certainly we might do that in kind of a fixed type of way, or we might do it in a way where we capture people's preferences to going to locations. And if the food court here on campus were shut down to prevent the Osgood epidemic, we might see students instead congregating in other areas like Tim Hortons, or indeed in Alexander's across the way, in ways that would lead them to spread the Osgood infection, in those new venues. And again, that would be treating as endogenous people's movement, where they spend their time. But again, it would depend on capturing of mobility, rather than depending on, a network with fixed connections to capture how the infection is spreading. Generally speaking, the further we go down on this list, just in time, thank you. The machines have arrived. Anyone who'd like a machine, we're going to be using AnyLogic in just a minute here. So the further we go down on the list, the more factors that are included, the more flexibility we have, the more types of effects we can capture, but also the greater complications. The more thinking we're going to have to do about, and potentially data we're going to have to collect about where people spend their time, or what their preferences are for spending the time in a way that would help us understand, if X were shut, where would they go in the absence of X? How would they simply substitute contact elsewhere for a given location? So mobility fits in here as a tool for investigating contact patterns at a deeper level, as well as many other phenomena. Okay, so I'm going to talk about how we capture mobility a little bit in AnyLogic, and then I'd like to fire up our AnyLogic so that we can actually do a little example that will illustrate these phenomena. It will illustrate dynamic populations, and it will illustrate indeed a little bit of embedding UIs. Okay, so within AnyLogic provides a set of methods for implementing mobility. The one we're going to use the most today is move to. And the idea here, ladies and gentlemen, is that agents are associated with a given velocity and a given target towards which they're headed. And you can change the target by using this method move to. So once you set move to, they will head towards a different location. I want to distinguish this indeed from set XY, which simply jumps them, teleports them, as it were, to a certain location. Obviously, we jump to. Set XY is used to set their initial location. Jump to moves them to a certain location in an instantaneous way. You know, beam me up, Scotty, and it beams them over to a certain location, XY. We can further set their velocity, and we can set their rotation. AnyLogic does not inherently keep track of their quantities of great interest at a physical level, such as momentum, and arguably at a psychological level, but it's readily layered atop of it if you were to implement it. And I would encourage those in the classroom with a more physical bent to try implementing an n-body, multi-body simulator in AnyLogic where you can capture gravitational effects, etc. It would be a great deal of fun. Okay, so these are factors for controlling agent movement. For interrogating agents as to their characteristics, we can ask them for their current X and Y location. We can ask them, are they moving? If they've arrived at a destination, they are simply awaiting orders and they may no longer be moving. We can ask what their target is, where are they heading to, and we can ask what their rotation is. Rotation is associated with their depiction in the screen. We'll be making use of a depiction which is isotropic, so it's invariant of its orientation. But if you make use of orientation of underlying presentation elements that are asymmetric, you'll see them move around and rotate. Okay, so I'd like you to call up an AnyLogic instance here, and I'm going to go create a new model. And as I am wont, I'm probably gonna ad lib a little bit here, so that so that the fun is not limited to you folks. Professors want to have fun too. Although our notions may be different than yours. Okay, so I did a new model, and I'm going to create a model. I called it movement towards mouse. I think I'm going to be a little bit more creative here, so it's going to be called initial mobility model, and that will let us change course as we see fit. So it's an initial mobility model. And we're going to use this to rehearse, in my fuguish sort of way, some of the basics of creating AnyLogic models. Now, I happen to have two different versions of AnyLogic running here, and it may slow us down a little bit. But here we go. Okay, so you folks tell me, how would I put in place a population here which is distributed initially uniformly over space, and they're all composed of circles. Now, you folks may be subversive, and you may want to impose other icons of sorts from your palette. Okay, so tell me what to do. Okay, I want to add an act agent. So this allows me to just mention en passant that when we do add active object, it turns out that this notion of active object has to do with the notion of a whole class of objects, which include the main class as well as agent class, which have a number of features. They have a presentation associated with them. They can be embedded in other agents or in other active objects, so they can be composed in nice ways, etc. So I'm going to add in a person, okay? Now I'm going to want a whole population of people as agents. So what do I have to do now, right after I create that? Good. We have to check the agent box. Good. Now some of this can be shortcut by dragging from over here, actually, but this is a good little exercise. And now I'll go back to main. I want to create, so where do I go to create my population of people? Well, okay, what should I do first even before I create my population? Presentation, good. It used to be much more painful if I forgot that, but let's go attend to that right now. So let's create the presentation. How do we do that? Okay, so the palette on the right, and we're going to go down to the presentation properties, and we're going to drag it over here. And I'm going to make this guy has a rather expansive spatial extent right now, and I'm going to shrink him down to be a smaller size, okay? And I'm going to center him on the axis. Why do I do this? Why do I undergo that ritual right now, putting him there? Well, the answer is I do it like so many of my actions on computers and in life because I foresee danger. And the danger here is if they're not centered there, there's going to be a displacement between their logical position and their actual position on the screen. If you place it at this origin here, what it means is they will appear physically at the screen at the same as their underlying logical location, which will ease in debugging, etc. Okay, so it's just one of those things that just sometimes sets aside a bunch of difficulties by just attending to it. Okay, so I put it there, great, and that will be the extent of our representation here of the agents. We're not going to do any fancy networks or anything. Okay, so I want a population of these people, and they're going to be distributed in space. So give me the next few steps. What do I do? Okay, go to main, and how do I add a population? Drag, good, excellent, excellent. Wow, you folks have been watching videos. I'm sorry to invade your home space. Okay, so we drag the population, excellent. Now, what do we have to do if this is, we want it to be a population of many people, let's say 100 people. What do I have to do? Excellent, 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 excellent. Singularly excellent. This is very good. So we'll make it 100 people. Great. Okay. And if I were to run this now, would there be 100 people in the population? Yes. Okay, what would the problem be? All atop each other. So what do I need to do to make them not atop each other? Great. And how do I set their initial position? What's one way of doing it really quickly? By delegating their control over their position to the environment. Okay, where do I put the environment? Is it in person? It's in main, yeah. It's a global feature of the situation, so it lives in main. Anyone, please ask me questions about this, because I've never covered this in class before. I know a kind of an avatar of myself has covered it for you on your screen before, but you've never done it interactively. So if there's any questions about these rituals, please tell me. Please ask, okay? Yes?
I'm just wondering about presentation.
Yes.
There's two types I noticed. There's 3D and there's presentation. What's the difference?
Yeah. So, you mean in the palette here?
Yeah, I think they have the same like squares, ovals.
Yeah. Yeah. So the fundamental thing is in AnyLogic 6, okay. So I guess I'm not seeing the 3D one here, but you can choose to either make use of a 2D environment or 3D environment, and you can make use of a 3D representation of scenes where you situate the camera at a certain angle, and you can actually see the various objects depicted in a three-dimensional setting. So you could see people, for example, moving around as sort of an animation in a 3D, not quite photorealistic, but it's they're rendered in a three-dimensional fashion. And so in AnyLogic 6, you kind of have to choose between these two, either a 2D or a 3D. the next version of AnyLogic, just everything's 3D by default. You can sort of depict it in 2D if you want to. But we're not going to be making use of the 3D here, but you could, and it's actually fairly easy to create sort of three-dimensional visualizations, renderings of the situation. Okay? Great question. Yes? Okay, the environment's up in the general properties. It's kind of a catch-all. Up here at the very top level of the palette, and it's the second to last item in mine. No? Okay. Thank you very much. I really appreciate you helping out with that. It looks, it looks like a world in a little bit with oceans. It also has a, what's that? Like a globe. It also, if you look at it, it also has a bizarre resemblance to a blue gopher. Or Barney the dinosaur, for those familiar with those things. But in any case, I think that's supposed to be the Atlantic Ocean in the middle of it, with a distorted view of the continents. Okay, so we put in the environment. Okay, what do we have to do to have the agents delegate their positions to the environment? Okay, so, excuse me? What do we have to do?
You have to tell the agent class about the environment.
Okay, do we have to tell the agent class about the environment? The population. The population, which is just, let me see if I can express why I'm emphasizing this. We don't have to privilege the environment by saying that the agent class can only use that environment. There might be actually persons in several different environments simultaneously, or sorry, let me put it this way. There might be different classes of persons, different groups of persons, some which are in one environment, some which are in another environment, and maybe all of them are in one environment or the other, but it's different environments, and that's allowed, that's supported. But what is required here is that a given population is associated with at most one environment. So it's associated with the population. That's the unit of specifying. We could have several populations, each of which is bound to a different environment. Okay? Okay, so we associate the population with the environment. Great. As part of that, we could go look at the environment here. Were you able to find the environment in the palette eventually? Yeah. Great, okay. So in the environment here, if you go to the advanced properties, you'll notice that with the specified, you have a layout type and a network type. Just to be explicit about it, we'll make the layout type random. Okay, we'll look at people at random. We actually don't require this. This is not required. Okay, so if we run this, should it show people scattered around space? Yes. Okay, so, sorry? So, oh, by the way, strong emphasis here. And I am kicking myself for not having done it. Build early, build often. What I mean by that is, when you're building up a model, please just as a matter of habit, and I'll sacrifice that just to emphasize this, do model build. There's often little buttons up here that will do it for you, but just reflexively build your model to make sure things are okay. It'll say build completed successfully. Do that to to know as soon as possible if something's off. It'll give you a hint as to what is off, and it will let you be corrected before you go far down that path. Okay? Okay, so here's our little environment. Great. So we've got this scattered around. Now, ladies and gentlemen, this should bring you to a familiar place. Now let's induce mobility on it. Okay? Maybe I'll crowdsource it here. I'll crowdsource it. I put it to you folks. I was going to have click and have all the agents gravitate towards where the mouse click was. But that's not very creative. It's kind of uninspiring. What sort of effect would anyone else suggest? Like, what if you wanted to see something interesting happen here? Maybe I click one of these guys and it zooms off, or maybe you want to see them bounce up and down. I don't know, or you want to see them head towards the nearest agent or something like that. What would you like to see?
Have them all move away from the click, and have either the boundary condition be periodic or a bounce.
Oh, okay. Okay, that's interesting. Okay, so certain parts of that are more trivial to to deliver on than others. Okay, let's start at the beginning, and we'll see where it takes us. Okay, so we want them to go away from the mouse click. Okay, first of all, I need something that receives the mouse click, that knows about the mouse click. So, and this is an awkward fact, but I need to introduce some object in the background that I can click on, and it will know where I clicked. So I'm going to introduce a canvas from our presentation. Okay, so we're going to go down to presentation here, and where is it? Here we are. And we're going to introduce a rectangle, and it's also going to be located starting at the origin, in this case, of the main environment. And I'm going to drag it off so it's nice and big. Okay, so the end result is I dragged a rectangle there, and I dragged it onto here. But I'm going to right-click on it, and I'm going to set the order to the back so that it's behind the ovals that will be in front of it for the ovals associated with the agents. Okay. Okay. So I've just done that, and this is why have I done that? I've done it because it is it will serve as the vessel for receiving the click. So when we click on it, it will be able to tell us where we clicked in the background. Otherwise, there's nothing to click on, and the clicks will be like trees falling in the forest. Okay? Like ships passing in the night. Okay? People comfortable with that? Notice I dragged this to main. I did not drag it to person. Yes? Question? Any questions?
Is there a way to get the size of the environment, I mean the pixel size of the environment, and set the XY that way instead of just?
Yes, there is. Great question.
I set it to 400 by 400, but honestly, it doesn't look like it's the same size as my 400 by 400.
Yeah. So we could, if we go there, we could try to set the width here, but I suspect that it's going to be an unhappy camper here associated with the rectangle. So we could say that this is associated with environment. You see, it needs a number. Eh? So what I can do is, this is great. We're getting a chance to discuss these things. Ladies and gentlemen, associated with each model is a set of handlers that handle events of various sorts, okay? One of the most important events is the startup event. So main has associated with it, in general, startup code that starts out, when it starts up, it can accomplish some tasks, right? So in that startup code associated with main, we could set this, what is this thing called? It's called the rectangle. And I'm going to give it a more dignified name than that. I'm going to call it background, I'll call it rectangle background, okay? And then associated with main, we'll say rectangle background. We'll see if we can, great, dot set, and unfortunately my autocomplete is not working. Someone try to complete it for me. Set width, does that work?
Yeah, set height, set scale.
Okay, okay, we're gonna do this, I'm kind of operating close, open loop here. I don't know what's what the correct thing is. I'm shooting in the dark, but it looks.
Set width.
Yeah. So I'm going to set the width of the rectangle to be the environment. Okay. And then let me explain what I've done here. So in this startup code, this is the code which will execute initially. Okay. And I'm going to, particularly those who are here for 858 and may not be familiar with this, I'm going to go enlarge this thing into a nice big form here. So there we go. Boom. Okay. Hey, no, not that big. It's wrapped. Pardon me. No. Okay, so it'll be rectangle background. That's the name of that rectangle. I say, hey, you set the width. And what width do I want it to set it to? I want it to be some number, some value returned from environment called that width. So I'm asking the environment, what's your width? And then I'm setting the background, the rectangle background to that width. This is icing on the cake. We don't need to do this, but I was trying to answer Dustin's question. Okay. Okay. Anyone want me to leave this up there for longer? This is kind of icing on the cake. It's not required. Okay. It's just set to kind of to normalize things. Okay. So let's run this thing here, and now we should see this this background. Great. Now the background needs to receive click events. Where do I go to have it receive? Where do I go if I want to know that I clicked on it?
Rectangle on click.
Good. It's the on click handler. Where is that handled?
In the dynamic tab on the.
Good call. Good call. So here we go. Go to the rectangle in main, and we go to the on-click handler here. And you'll notice that there's this little thing which pops up here, which gives you hints as it is its function. And here it says use click X, click Y to be the shape relative coordinates of the click. In other words, it will tell you where on it you clicked. Okay. Okay. So that's great. So I think I'm going to start. I'm going to start with. I think I'll start with some things that will show some features of this, and then we'll work up towards this suggestion. Okay, first I'm going to have this. When we click on it, I'm going to I'm going to get the nearest agent, or reference the nearest agent. I'm going to have that nearest agent head towards this location. Okay? How would I do that?
Send a message, the nearest agent, move towards this coordinate.
Yep, we could do that. But it turns out we don't even have to do it through messages if we don't want to. I can actually get the can I? I can get the nearest agent to another agent. The question is, can I get the nearest agent to this one? Not actually sure about that. Let me instead, rather, because I don't have autocomplete, what I'm going to do is I'm going to loop through all agents, and I am going to set all their targets to be this location, and we will see them gravitate towards here. So that's going to be simpler, and I don't need to use autocomplete for that. Okay, so what should I do to iterate over all agents? You could do it with that, but there's a more elegant way to do it yet, since Java 5. Iterator? Good. So we can iterate for person P in population. In other words, for each person in the population, we can have the P dot for that person. We can set P dot move to what's our current location? Click X, click Y. Where is that coming from? It's coming from this little hint here. Okay, so what I've done here, I'm going to put it into the big window here, is this. Okay, this is in the on-click handler under the dynamic properties associated with rectangle. And what does this mean? It means, hey, go over for each person in the population, name them P, and execute this thing for them. Namely, we're saying, hey, P, move yourself to this location and that thing. Now, are people comfortable with that? We're saying, move to this destination. And presumably it's going to say, yes. Yes, sir, yes, ma'am. What's that?
Just a comparison between messages and what we're doing here.
Yes. Yes.
It seems here,
Yeah.
God, if you will, is directly changing the intentions of each individual
Correct.
person. Whereas when you're sending messages, it's more like God sending an email to each person. Is that sort of what's going on?
Well, instantaneous email. But actually, it's more nuanced than that. Theology aside. So by sending a message to each person, you'd be treating it at a higher level of abstraction. You basically say, okay, this event of some sort has happened. You probably need to name it, like you now want to move to this location or whatever. And you might actually have rather articulated logic within a person about what to do that you build up over time. Like maybe initially they move to that location just flat out, right? But maybe over time you build up logic that says, well, some people would definitely move right away. Other people would be inclined to ignore it, or maybe there'd be logic associated with their response to it. If they did it in the past, they won't do it this time, or what have you. So what I'm saying is, this is a very how shall I put it? This is a very stricter brute force is not quite the word. It's a very sort of narrow way of doing it. We're just taking control and we're saying, just do this one thing. But it would be much more general if we delegated exactly how the agent responds to the agent. We just say this general type of thing occurred, like there's cheese in the middle of the room, and the mouse might respond more, strongly, or it might respond less quickly. Maybe it has a nest full of pups to take care of, in which case, it initially doesn't go for the cheese, or it goes later. And so the point is, I wouldn't do this in a real model, just like by fiat saying, go there. Yeah.
So it sounds like this is sort of like God is directly making you do something.
Yeah.
You don't have a conscious choice about it, but
Yeah.
whereas if we're using messages,
Yeah.
it would be more so like God is telling you, I want you to move there, and then the person can say, well, okay, I'm going to follow that, or I'm going to do something else. I can make my own choices based upon that message.
That's right. It would be more, you could make it more of an emergent property, the simulation, how they react.
Yeah, okay.
In other words, it might depend on their history and their past. Maybe before they went for the cheese and they found it was plastic cheese and they don't want to go there anymore. Or maybe it turned out to be poison before and they got sick and so they don't want it. And so the point is there'd be more flexibility for turning it into a richer model.
Yeah.
Whereas this is suitable for student instruction, but not much else. Okay, so we could run this thing, and we could go click here, and we will see a congregation, and then we could click in different areas here, and see a general movement. You'll notice it stays in effect as long as I'm not re-clicking. And sometimes for reasons I don't fully understand, I'm actually having to double click. But you could see more and more these are becoming point masses. which might not have been something I would have predicted, how uniform their location is becoming. Okay, so we've seen here a little animation. What I want to do now is actually weave in some additional elements of this. So maybe what I'll do is I'll have it so when we click on a person, they disappear. They're deleted from the population. Okay? So tell me what to do. Where would I go? Would I go to the rectangle?
Go to person and then the visual representation.
Yeah.
Click.
Okay. Now, I'm going to do something here which some of you may have done before, and it's to illustrate a point. So, wait. Okay, where? Yes, exactly. So you got to be really clear about where you're clicking, and don't be fooled by the fact that main actually has a representation of the person here. That's just showing where the person, for this population of people, where they're based, where their origin is. You can't actually set their key properties like for the oval through that. To do that, we have to go to person here, and we have to set go set in their dynamic properties, and we could then, what do we do then? Anyone? Okay, and one of the reasons I'm telling you about this is because you may need it in this problem set or others, and you might be looking for it in the wrong place. You might think that you would just say this dot destroy, in other words, like destroy me, but it turns out that doesn't go. I actually mentioned it last time briefly in response to a question. What is responsible for remove from environment? You remove it from the population. It turns out the environment takes care of organizing them spatially in terms of connectivity, but it's the population that's the fundamental collection of people. Now, I don't find this particularly intuitive or whatever, but I'm trying to speed you on your way towards being able to respond to things. So. The software engineer in me revolts against what I'm about to do, but to spare time, I'm gonna do it. And just don't do this at home, please. Okay. I need to ask the population to remove them. Really, what I should do, by the same token as what was mentioned earlier, I should really call off to the main class and basically say, hey, delete this person, and it will know how to take care of deleting them. But instead, I'm going to go and I'm going to reach into the innards of that main class, and I'm going to tell it, the population, just delete me. So how do I do this? Well, right now I'm in person. I need to get, if I say this, that's referring to me as a person. It's me. I can ask myself questions by saying this, dot, whatever. I need to get the main associated with me. So I say this dot get underbar main. That will give me a reference to main. Okay? And then guess what lives in main? The population. That's the thing I want to use. But I actually, and this is where it gets this is where it gets unpleasant. I actually need to tell it remove. I call it, this is actually a method in main called remove underbar population. Again, I can't use autocomplete, so I can't verify this. If someone could verify I've done this correctly. Yeah. So what's going on here? Can I put it up on the big screen here? There we go. Okay. This is in the on-click. This means me. Why does it mean me as a person? Well, it's because I'm in the person class, and I'm doing things with respect to some particular person. It's my oval. It's my state chart, and so on. It's my variables, and this refers to me as a person because of that. Now, this .getMain gives me a reference to the main class, which I need, because I need to ask it to remove me over here, this, from this thing called population. Now, this troubles me, that you have to do this, that there's this special function called remove underbar population. If we had called the population pop, it would have been remove underbar pop. There's nothing particularly privileged about population. It's just the name of our population. Whatever we named it, if we call it people, it would be remove underbar people. Okay. So this is saying remove me from the population that lives in Maine, and this is how I get to reference to Maine. Are people comfortable with that? Yeah? Okay. So should we try it? Build early, ladies and gentlemen. Build often. Okay. So we just built it. Let's go. Run this thing. Okay. Okay. And let's first of all we'll click here. Okay. It's moving. Now let's click on one of these things. Oh, look at that. Boom. Okay. Yeah. Wow. Okay. So we've just removed some. Now I wish we let's go add. Okay. The first UI element that you're going to add. I'd like you, ladies and gentlemen, to add a button that will add people to the population.
We had a score counter after that.
Sorry?
We had a score counter. Like the game.
Yeah, power to you, young man. Absolutely. So you can coordinate with others, and I would love to see something come out of this. So let's so we're going to put a button so we can add people in. Where would that button live? Okay, it'll be from controls, but does it live in main or in person? It'll be in main. Let's go down to the controls area and let's add in a button, right? Let's add it just, you'll notice in a lot of AnyLogic models, it hides things just off from visible. So we'll put it just above here, okay? And this will be a button, and it will be called button, add person, and its label will be add person, okay? So we've just added this button, and you can see I just saved it in its add person. And how are we going to make this button add somebody to the population? Anyone?
Action on click.
Yeah, exactly. Well, okay. So actually, we just put it in this action here, yeah, and it's on. Yes, this is the action when it is clicked. Good.
So we would do like this get main.
Okay.
And run get to the population that way again.
Fortunately, we're already in main here. We're not, because we're doing this in main, we don't actually have to ask for main. Instead, we could just ask this dot, and instead of remove population, it's add underbar population. Okay? By the way, if my person had parameters like income, sex, age, whatever, we could pass those as parameters here. So there'd be characteristics of the person being created. Does that make sense? Okay. So who needs help here? Okay.
Here, for one, add population
Oh.
is an autocomplete. When I go to build, I get a method add population is undefined for the type person with a capital P.
That's because you probably added the button to person rather than to main.
Oh, yeah. That's true. There you go. Thanks.
Okay. You could cut it and then go to main and paste it and spare yourself a bit of trouble. Okay, other questions? These are great question there. So others? Okay? No? Okay, let's go and simulate this. Okay. So ladies and gentlemen, let's where's the button? It's up there. So I have to use right click. I can't remember what it is on Macs. Is it is it command click? I can't remember, but you could drag it around. And here's our button. And here we go. You see them? You see them? Yeah. They're being added in. Maybe we should add a score counter. Okay. And now we can click, and here we have this movement. But, you know, it's not, we haven't really taken advantage of a key feature, which is when a person arrives at the destination. Does anyone have any questions or any help needed? I'm glad to come back. Yeah. Sorry? Because we said here add underbar population, and population is a population of people. So it'll just add that in. Good question. Other questions?
Yeah, just back to the button thing. So you say we're already in main, that's why we can do this add population.
Yeah.
I'm just wondering, isn't the button its own object or something that resides in main?
Good question. Turns out that that you're writing code here that it doesn't live. Believe me, I've had that confusion before. This code doesn't live in any button inside any button class. It lives in the class associated with main as a whole. So this refers consistently, and I think this is pretty much true anywhere within the code you write associated with main. It refers to main as main. It's a great call to ask that. Yeah.
I just noticed something playing around the simulation is that if you click, move the mouse, and then unclick, it doesn't register as a click event. So if down press coordinates and release coordinates are different, then it won't register as a click event.
Okay, that's interesting. So click, drag, click, or click, drag, unclick rather. Yeah. Well, that would explain one or two things I've seen. So maybe that's sometimes why it seems to be ignoring clicks, is because there's a slight movement. Okay, good. Thank you for mentioning that. I'll see if I could pass that on. Okay, great. So we've just added a widget. Let's go add a widget for the speed, right? Let's add a widget for the speed of all the.
Can I ask you another question?
Sure.
On the bottom right of the corner of the simulation, the active simulation screen, it shows your memory usage, and currently I'm at about 12 megabytes, I assume, of 62 megabytes. And it keeps on increasing over time, and then once it hits a certain value, it decreases a whole bunch.
Yes.
As if, there's constantly more stuff being added to memory, and then, it deletes a bunch, cleaning it up as if it's not used. So
Yeah.
two questions. Why is it constantly using more memory even when I've clicked on and deleted all the agents? And then what is the process that is freeing up some memory?
I'm watching here. So one thing that's going on is, and this will be covered in a future lecture, but what's really going on behind the scenes here is there's a quite sophisticated what's called an event scheduler that's sort of taking care of managing all these things. And events go off at many different times in the course of the simulation. You could see statistics regarding those events if you were to go. It's down here. For example, events per second that are generated here. Okay, actually, there's there's some events. In my case, I don't see it monotonically increasing like that. I see it kind of oscillating. The reasons it could increase if you're dealing with a lot of events, or there's a lot going on, like messages being sent as an example, something that would require memory, etc. The process that decreases the memory sometimes is garbage collection. For larger models, one thing you may want to do is down here in the simulation, you may want to go to advanced, and you can actually allocate this thing more memory. in which case it will be less memory constrained and won't have to do garbage collection as quickly. Okay. So those are some good questions. But ladies and gentlemen, what we've done right now is sort of it's not really taking advantage of the fact that agents, you in general like them to be somewhat self-aware. I mean, they're aware of what's going on, and we kind of just kick them off in different directions. Let's have the agents respond in some sort of way to be active members of their context, so they're not merely so passive. So, sorry?
What about bouncing off of other person?
Yeah, I like that idea. Let's work towards that. Okay, so let's go drag in a state chart. So in person, let's drag in a state chart. This will be called mobility state chart. And then let's just trying to trying to think how best to handle this. So we're going to have a state which is going to be sort of at rest, something like that. And then maybe we'll have a state in motion. And maybe we'll go to in motion based on receipt of a message, based on the comments earlier. And critically, this is the main thing I want to emphasize here. From an in motion state, we'll go back to at rest under what condition? Does anyone want to advance it? Advance an idea? Under what condition will we go back to at rest? Agent arrival. It's then that they arrive at their destination. Okay? Okay, they're initially start at rest. And we need them to put themselves into motion. Okay? So here we're gonna either need to give them some information about where to go, or we will have them go in a random direction. So just thinking about the limited time available for us, if only Java had a nice pair construct that could be a single object that would wrap up the destinations to use. I could pass it as a thing in the message, and we could give them a nice destination to go to. But I think what I'll do is in this in motion, we will just set them going in some random direction. Okay. Okay, I like that idea. So your idea was have them go towards, what was it, the nearest neighbor? No.
Like go away from the mouse click?
That was the original one, but then you had a
Collide.
Collide, okay, yeah. So they'd respond when they collide.
Then you'd have to have like non-definite size, or non-point size.
Yeah.
There would have to be a definite size of each person, and then
Right.
calculate the angle so they
Exactly, which may be too involved for here, although I'd encourage it. Okay, let's have them go to their nearest neighbor. How about that? Okay, we'll have them go to their nearest neighbor. Okay, so how are we going to get their nearest neighbor's information?
They stuck at nearest neighbor.
Good call. We'll have person nearest neighbor. We're declaring a variable here called nearest neighbor. It's a person, a reference to a person. And we're going to do this dot get nearest nearest neighbor, I think it's called. Now, we might have to pass it, yes, we'll have to pass it. Get nearest agent, thank you. Get nearest agent. Let's see if it's happy with that, okay? No, it needs to know, well, you have to give it the entire collection of agents, okay? So how would we get, give it the population? We'd say what? This.getMain. We need the getMain because we're in person and we need to get a reference to main, and then we say dot population, right? Okay. So let me put that up there on the big screen. There we go. Oops. And I'll split it into two pieces. Okay. Person nearest neighbor equals, this is declaring a variable called nearest neighbor. Where does that come from? It comes from, we're going to be calling this, that's this particular person, get the nearest agent, and then it has to get the nearest agent out of the entire population in Maine, the entire population. And there should be a semicolon at the end. Okay? So here we get the nearest neighbor, and then what do we do? Move to it, yeah. So I say this dot move to, and what are its coordinates? Nearest neighbor dot get x, nearest neighbor dot get y. So we're asking that nearest neighbor. When we first get a reference to this nearest neighbor, we find out who that nearest neighbor is, and then we say ourselves move to a location defined by that nearest neighbor's x location, that nearest neighbor's y location.
I don't mean to belittle what you've just done, but there's actually a function move to nearest agent.
Oh, well, I'll be. Okay, this dot move to nearest agent.
Yeah, and then it takes in the this dot get made up population.
Oh, okay. Okay. Let me go back and get that. Okay, wonderful. This dot move to nearest agent, like that. Yeah. I'll put it up here. Move this dot move to nearest agent, and you give it a population.
I think so.
Good. Okay. This dot move to nearest agent, and inside its parentheses, in other words, passed as arguments, it needs information about, out of all agents, which ones do you want me to find the nearest ones? And it's this out of the population that lives in Maine. I have to get to it through my get Maine. Say, who's my Maine? Okay, great. Okay, that's good. Now, just to spice this up, because I don't want to have to send messages. I'm actually gonna change this guy here to be instead of being a message, I'm gonna make it a timeout with a rate of 1. Okay, so now we're going to move these people with a timeout of 1. But okay, so who needs help? Who needs help? Look at that.
Just a quick clarification.
Yeah.
Timeout is the exact value, and then rate is kind of like the distribution.
No, rate is just like a first order delay. It's a certain chance per unit time.
Yeah, you'll end up
Okay.
getting the Gaussian.
After that thing, whereas the timeout is the exact time. Sorry? It stopped is exactly right. Here I could move it, and then I can. Oh, look at that.
Interesting behavior concerning their inner decision about which event to follow your click or moving to the next.
That's right. Okay. So there's actually victory pulled out of the jaws of defeat here. So we had two very simple behaviors, folks. One, we click here and they all move towards it. and another, periodically, agents start moving towards their nearest neighbor. And now we have kind of a weird hybrid of the two, where they kind of get stuck sometimes going past other agents, and they almost, okay, that's that ain't that nifty. That's really great. Wow. This is what's called professor fun. Anyway, what we've seen is agents, when they reach a location, they then stop, and then after a certain period of time, they kind of they head off again. Now, how would we do it? Wow, that's really interesting. Okay, I got to stop this. Okay, so now let's change it so that their speed depends on a slider. How do we do that? First of all, where did the slider live? Okay, in main. So let's go over to main, and let's go down to controls, and let's go drag a slider up here. And this will be called velocity slider. Slider. And now riddle me this, folks. Whenever the slider is changed, I want to set the speed, the velocity of all agents in the model to the value of the slider. How would we know that the slider's been changed? Let's start there.
There's an action field.
Okay, there's an action field, and that's exactly right. Okay, so in the action field, what do we have to do?
Iterate through the agents and set their speed.
Good. Okay, so you tell me what to type.
Maybe this dot get dot population. Before.
Okay.
Or person P.
Person P colon.
This dot population.
Yeah, or this dot population would be a sort of more precise way of saying it. Okay. Okay. And okay, we're going to iterate through each person, and for that person, what are we going to do?
P dot set velocity.
Good. Set velocity to be whatever the value of the slider is, right? And really, I would have done it slightly differently before, but this is called velocity slider dot get. Can you say get value? You folks tell me.
No, there's no value.
There's dot get. There's something very similar to that. Get.
Value, get value.
Yeah, there's a get value.
Okay, and it returns a double.
Yeah.
Okay, so that is that what you're thinking, Curtis?
Yes.
Okay, so let me go paste that up in the big screen here. There we go.
One of the students left there.
Oh, thank you. Thanks very much. Where were they in the classroom?
Over there.
And was it someone from today's class?
Yes.
Okay, great. The guy with the red shirt who left earlier?
No. It was a girl.
Oh, okay. Okay, thanks very much. Oh, I know. That's Sarah. Yeah, thank you. Okay, great. Okay, so I iterate through each person's population. I set their velocity to the value of the slider. So I'm asking the slider, give me your value, and I'll expand it over there. And then whatever value it gives me, I'm giving it as the argument to it. In other words, the information passed to set velocity to do its job. Right? Okay, and that's on each person in turn. Does that make sense? Okay, shall we run it, ladies and gentlemen? Okay. Okay, so let's go see this, and now let's oh, look at that. See that? Did you folks see that? Watch this. This will be like the the slow and steady, and then watch this. Boom. Now we're cooking with gas. Okay. Okay. Wow. Okay. So now let's do one more slider. You tell me exactly what to do. We want to set a slider to change the rate at which the agents start moving towards the nearest agent rather than towards the globally dictated destination. Where would I do that? Where's that rate defined? First, let's add the slider. Divide our difficulties. So add a slider in so that we'll change the rate at which they go towards the nearest agent instead. The greater the likelihood of switching into that mode. Anyone? How would I add a slider? Oh, come on, you can do that. Okay. Okay. Thank you. And this one will be called slider companionship preference. Something like that. Slider companionship. Okay. Okay, fine. Great. So, and we want it to go from 0 to 5, maybe something like that. Okay. Great. Okay. Now, where do we use it? How do we go use it? Anyone?
We're going to iterate over all the persons again, right? And then we're going to change so person dot their state chart.
We could do it that way. What's another way to do it? Within their rate, the value of their rate would depend on the slider directly.
Is it something you want to change for each instance of a person, i.e. all members in the population? Or is it something you want to change for person overall, like the superclass?
Well, that's a good question. I was thinking of changing it for all people in the population for simplicity, but I don't feel really strongly about it. We could set its value, then when we click on a person, it sets their rate. That'd be one way to do it. Or we could just do it for all people in the population. Let me show you one way to do it, okay? That will show, and actually I don't terribly like this way, but it does show one principle. Okay, so slider companionship, and then I could go down to person, and in person's rate here, we could go have this depend on that slider. How would we have it depend on the slider? How do we refer to that slider? The value of that slider. This dot get main dot slider companionship dot get value. Right? That's the value of that slider. We don't need a semicolon because we're not telling it to do something. We're just getting it to computer value. So this is an expression, not a statement. We're not telling it to a command. We're instead saying, hey, give me this value. Does that make sense? Okay, so yes, get my reference to my main, get the companionship and get its value. Okay, and then I do build, and then let's run it. Okay. Okay. There'll be lots of opportunities for exploring this more in the problem set. Okay. Okay. Oh, you know what? Oh man. It's actually not. I know what's going on. You notice it's actually ignoring the companions right now. Why is that? It's because, ladies and gentlemen, this value was initially 0, and so they're never actually getting out of this state because it was set to a rate of 0. It said, oh, that will never occur. So it doesn't actually get these updates. To get these updates, this is actually another important principle. What I'm going to do is to create a transition within this that will periodically, at least every one time unit, it will recompute its rate based on the current value of the slider. Now we're talking. Now it's going to be able to adjust it. Initially, sorry? So what I said is that when I ran this earlier, I noticed that none of them were paying attention to their neighbors anymore.
Yeah, because the default value is 0, right?
Default value is 0. And so the key point is with a default value of 0, it's never going to emerge from this state, okay? So and it's never going to recalculate its value automatically. There's two ways to get it to recalculate value. You can call onChange to get it to recalculate it, or a trivial one is to just get it to periodically, actually, sorry, that's not actually going to do it. That won't cut it. What you have to do is you have to get it to leave this state and come back in like that. Ooh, sorry. Oh man. Let me redo this. Oh gosh, this looks like this is horrible. Oh man. Okay, there. Now we're getting less bad. Come on. Hey. It'll work fine, but it's just ugly. Okay. Hey, get back there. Okay, with this here, I'll move this over like that. Okay. Okay. So what I did is I created a transition that goes